We'll start in 1 minute. Today we'll be in section 6.3 in the first part of factoring special products. So remember, factoring is the reverse process of multiplying, and you can check your factoring by multiplying. The first step in factoring is to factor out the greatest common factor of all of the terms. The first special product that we'll look at are called perfect square trinomials. Perfect square trinomials have two forms. One is a to the second plus 2ab plus b to the second. The other form is a to the second minus 2ab plus b to the second. The two binomial factors of a perfect square trinomial are identical. So if we factor a to the second plus 2ab plus b to the second, the two binomial factors are the same, a plus b times a plus b. Since the binomials are the same, we can write the factorization as the binomial a plus b to the second. And the other perfect square trinomial, a to the second minus 2ab plus b to the second, its two factors are a minus b times a minus b, or you can write it as squaring the binomial a minus b. If a trinomial isn't recognized as a perfect square trinomial, then it can still be factored by using the AC method. Okay, we'll look at some examples. Factor the following trinomials. Well, this one, 9x to the second plus 12x plus 4. So a couple of things to note. The term on the left, 9x to the second, is considered a perfect square because if you square the term 3x, you get 9x to the second. The term on the right, 4, is a perfect square because if you square the number 2, you get 4. So we might wonder if this is a perfect square trinomial. So one thing to keep in mind, just because the term on the left is a perfect square, and the term on the right is a perfect square, doesn't automatically mean that the trinomial is a perfect square trinomial. The middle part has to have the same, has to have the correct form. So we'll go up here and check. We'll look at a to the second plus 2ab plus b to the second. The middle term has to have the form 2 times a times b, where a is the square root of a to the second and b is the square root of b to the second. So we can check, does this have the right form? We'll write, in the middle, we'll write plus 2 times 3x times 2. So if you see what I'm doing, I'm writing this in the form a to the second plus 2ab plus b to the second. If it turns out that the middle term, 2 times 3x times 2, is equal to 12x, then we know that we have a perfect square trinomial. Okay, and sure enough, 2 times 3x is 6x, but 6x times 2 is 12x. So this is a perfect square trinomial. That means its two factors have the form, well, if we have a to the second plus 2ab plus b to the second, the two factors are a plus b and a plus b. So if we apply that to this perfect square trinomial, one factor is 3x plus 2. The other factor is identical, 3x plus 2. Okay, as I mentioned, even if you don't recognize a perfect square trinomial as a perfect square trinomial, you can still use the AC method to factor it. So let's go ahead and, just for practice, we'll use the AC method. So now we're going to factor the same trinomial, 9x to the second plus 12x plus 4, using the AC method. The greatest common factor of all three terms is 1. So step 1, we multiply 9 times 4, and we get 36. And then we look for two integers that have a product of 36 and a sum of 12. Well, those two integers are 6 and 6. 6 times 6 is 36, and 6 plus 6 is 12. Hey, another observation that is worth remembering, just one of those small details that will be helpful. Whenever you use the AC method to factor a perfect square trinomial, the two integers that you are looking for will always be the same. That's what we have here, 6 and 6. But even if you don't remember that, you just proceed with the AC method, transform the trinomial into a quadrinomial, write it as 9x to the second plus 6x plus 6x plus 4, and then factor by grouping. Out of the first two terms, the greatest common factor is 3x. We factor 3x out of the first two terms, and the binomial is 3x plus 2. The middle operator is addition, so we bring down addition. And then when we group the third and fourth terms, 6x plus 4, the greatest common factor is 2. factor 2 out, we're left with the binomial 3x plus 2. And then the last step, factor out 3x plus 2. The other binomial is identical, 3x plus 2. Okay, so there's no excuse for not being able to factor a perfect square trinomial, whether you recognize it as a perfect square trinomial or use the AC method. Okay, the next example, 25y to the second minus 40y plus 16. The greatest common factor of all three terms is 1. But notice the first term on the left is a perfect square, because if you square the term 5y, you get 25y to the second. The term on the right, 16, is a perfect square, because when you square the term 4, you get 16. And we want to know if the middle term has the right form. Okay, so this time we're looking at this perfect square trinomial up here, a to the second minus 2ab plus b to the second. So we want to know if this trinomial has the right form, a to the second minus 2 times a times b plus b to the second. Okay, so up here we have minus 2. And the term that takes the place of a up here is 5y. And the term that takes the place of b is 4. And then we check. Minus 2 times 5y times 4 is minus 10y times 4, or minus 40y. So this is a perfect square trinomial. And if you have a perfect square trinomial of this form, the two binomial factors are a minus b and a minus b. Okay, so we apply that to this perfect square trinomial. One factor is 5y minus 4. The other factor is the same binomial, 5y minus 4. Okay, let's use the AC method. So the AC method, so we're going to factor the same one over again. Factor 25y to the second minus 40y plus 16. So we multiply 25 times 16, and we get 400. Two integers that have a product of 400 and add up to negative 40. So what are they? What are the two integers that have a product of positive 400 and a sum of negative 40? So go ahead and type it in. Two numbers that have a product of 400 and a sum of negative 40. Well, if they add up to negative 40, they both must be negative. Yeah. So negative 20 and negative 20. Negative 20 and negative 20. So having the right sign is important, they both must be negative. Okay, so then transform the trinomial into a quadrinomial, 25y to the second minus 20y minus 20y plus 16. And then factor by grouping. Out of the first two terms, 25y to the second minus 20y, the greatest common factor is 5y. And when you factor 5y out, you're left with the binomial 5y minus 4. And then bring down the middle operator of subtraction. And out of the third and fourth terms, the greatest common factor is 4, but we want to factor out negative 4. So negative 20y divided by negative 4 is positive 5y. And 16 divided by negative 4 is negative 4, so we write minus 4. Okay, the two binomials match, so our complete factorization, 5y minus 4 times 5y minus 4. In this course, for the rest of the course, perfect square trinomials will be appearing in several places from now on. So make sure that you're familiar with perfect square trinomials. Okay, another special product is what is referred to as a difference of squares. So a difference of squares has the following form. A to the second minus b to the second. The difference, the term difference refers to the fact that we're subtracting, and a difference of squares implies that we're subtracting one thing squared from another thing squared. So hence the term difference of squares. A difference of squares factors really nicely. The two binomial factors of a difference of squares are conjugate binomials. So for a to the second minus b to the second, the two factors are a minus b times a plus b. They are referred to as conjugate binomials because one of the binomials has minus, the other one has plus. But the terms used are the same, a and b in both. So a minus b times a plus b. You can verify that these are the correct factors by multiplying. So let's go ahead and multiply a minus b times a plus b. We multiply a times a, which is a to the second, and then we add a times b. And then we subtract b times a, so minus b times a, and then we subtract b times b. Plus ab minus ab, those add up to 0. So minus b times a is the same as minus a times b. So these add up to 0, and then we're just left with the difference of squares, a to the second minus b to the second. Okay, let's factor the following polynomials. So 49m to the second minus 36. Notice that the term on the left is a perfect square. 49m to the second is a perfect square, and 36 is a perfect square, and we're subtracting. So we can think of this as the term 7m to the second minus 6 to the second. So it's more obviously a difference of squares. So the two factors are 7m minus 6 and 7m plus 6. And that's all. That's all we have to do on that one. Uh, 64y to the second minus 81. Notice the term on the left is a perfect square. The term on the right is also a perfect square. 64y to the second is equivalent to squaring the term 8y. And 81 is equivalent to 9 squared. So a difference of two squares. One factor is 8y minus 9. The other factor is 8y plus 9. And we're done. That's the factorization. I didn't acknowledge, so I want to make sure that I don't overlook this too frequently. The greatest common factor of 49m to the second minus 36 is 1. And also in the other difference of squares, the greatest common factor is 1. Okay, the next topic, sum of squares. A sum of squares has the following form, a to the second plus b to the second. So sum, S-U-M, refers to addition, and we're adding squares, a sum of squares. Okay, a sum of squares can be factored, but a sum of squares cannot be factored with coefficients that are real numbers. So in this class, Math 1108, we're going to be satisfied with saying, well, we cannot factor this with real numbers. So 4x squared plus 9y to the second. It is factorable, but in our little universe, we're going to say not factorable. What we really mean is that it's not factorable with real coefficients. You have to go outside of the real numbers to factor a sum of squares. If you take college algebra, you will learn how to factor a sum of squares in that class. Okay, let's look at some more examples. Factor the following polynomials. 64a to the second plus 112a plus 49. The greatest common factor of all three terms is 1. Okay, but notice the term on the left is a perfect square, 64a to the second. That's the same as squaring the term 8a, because 8a times 8a is 64a to the second. The term on the right, 49, is a perfect square. That's the same as squaring the number 7. Remember that just because the term on the left and the term on the right are perfect squares, that doesn't automatically mean that the trinomial is a perfect square trinomial. But in this class, most of the time it's going to be a perfect square trinomial, but just don't assume it automatically. We want to check to see that it has the right form for the middle term. So a to the second plus 2 times a times b plus b to the second. This is the form of the perfect square trinomial that we're checking. So in the middle term up here, we're going to write plus 2 times 8 times capital A times 7. And then we're going to check to see if 2 times 8a times 7 is 112a. Well, if we multiply the numerical factors, 2 times 8 is 16, and 16 times 70 is 112, and 112 times a. Okay, so this is a perfect square trinomial. The two factors have the form a plus b times a plus b. So the two factors of our trinomial up here then are 8a plus 7 times 8a plus 7. Here, the next example, 75b to the second minus 180b plus 108. So what should we do to start with on this one? How do we get started on this one? 75b to the second minus 180b plus 108.
You find the greatest common factor?
Yeah, find the greatest common factor. What is the greatest common factor? Huh?
1.
It's bigger than 1. Well, we can note that 75, I'll do some of that stuff up here. 75 is 3 times 5 times 5, 3 times 25. So the prime factors of 75 are 3 times 5 times 5. Uh, 180 well, 2 goes into 80, 90 times. 2 goes into 90, 45 times. And 45 is 3 times 15, and 15 is 3 times 5. Yeah, that's right. That's the prime factorization of 180. The prime factorization of 108. Well, 2 is a prime number. 2 times 54. 54 is 2 times 27. And 27 is 3 times 3 times 3. So if we just look at the prime factors of each of those 3 numbers, we're looking for the factors that are common to all 3. Yeah, 3 is the greatest common factor. 3 is a factor of 75. 1 factor of 3 is a factor of 180. Well, more than 1, but we're trying to match. So each one of those numbers has a factor of 3 in common. So the greatest common factor is 3. Okay, so we have to factor 3 out of all 3 terms first. So 3 goes into 75b to the second, 25b to the second times. 3 goes into minus 180b minus 60b. And 3 goes into 108 36 times. Now we turn our attention to the trinomial, 25b to the second minus 60b plus 36. Okay, we'll look at that in isolation by itself. Notice the term on the left is a perfect square, 25b to the second. The term on the right, 36, is also a perfect square. 6 squared is 36. So we wonder if it's a perfect square trinomial. So we're going to check to see if it has the right form. 25b to the second is the term 5b to the second. 36 is 6 to the second. So we want to verify whether or not our trinomial has the form a to the second minus 2 times a times b plus b to the second. So this middle term, if it's a perfect square trinomial, has to have the form minus 2 times 5 times capital B times 6. And sure enough, 2 times 5b is 10b, 10b times 6 is 60b, so it has the right form. So that means it is a perfect square trinomial. And the 2 factors of this perfect square trinomial are 5b minus 6 times 5b minus 6. Okay, but remember what we started with. We started with this trinomial where the greatest common factor is 3. So our answer is 3 times the 2 binomials, 5b minus 6 times 5b minus 6. All right, the next one, 16xw to the second plus 64x. Hey, what's the first step?
Greatest common factor.
Yeah, find the greatest common factor. So the greatest common factor of the terms 16xw to the second and 64x. Well, first look at the numerical factors, 16 and 64. 16 is a factor of both 16 and 64. 16 times 4 is 64. So they each have a common factor of 16, and they also have a common factor of x. Hey, so we can at least factor that much out. When we factor 16x out, we're going to be left with w to the second plus 4. So now the question is, can we factor w to the second plus 4? Well, every polynomial is factorable. but this is a sum of squares, w to the second plus 2 to the second. So we cannot factor w to the second plus 4 with real valued coefficients. It is factorable, just not factorable with real numbers. So this is our answer for the factorization. Notice that it would be incorrect to say that the original polynomial is not factorable because we at least factored it this much. So this is the complete factorization for our purposes. In this course, we just won't take it further than that. Okay, the next example, 9c to the second plus 42c plus 49. The greatest common factor of all three terms is 1. The term on the left, 9c to the second, is a perfect square because if you square the term 3c, you get 9c to the second. The term on the right, 49, is a perfect square because if you square 7, you get 49. So we want to check to see if the middle term has the right form for a perfect square trinomial. So we're checking to see if it has the form a to the second plus 2ab plus b to the second. So if it has the form of a perfect square trinomial, then the middle term is plus 2 times 3c times 7. 2 times 3c is 6c, and 6c times 7 is 42c. So that verifies that it is a perfect square trinomial. So the two factors have the form a plus b times a plus b. And so the factorization of this perfect square trinomial is 3c plus 7 times 3c plus 7. And a reminder, the AC method works. So we can do that real quick. AC method. Uh, 9 times 49 is 441. Two integers that have a product of 441 and a sum of 42, or 21 and 21. So just another reminder, if you're using the AC method to factor a perfect square trinomial, after you multiply a times c, the two integers that you're looking for are identical. Okay, so you transform the trinomial into a quadrinomial and write 9c to the second plus 21c plus 21c plus 49. and then factor by grouping. Out of the first two terms, 9c to the second plus 21c, we can factor out 3c. And the binomial that stays behind is 3c plus 7. Bring down the middle operator of addition. Out of the third and fourth terms, 21c plus 49, the greatest common factor is 7. Factor that out, and the binomial is 3c plus 7. And then factor 3c plus 7 out, and the other factor is also 3c plus 7. Okay, we'll move on to the next page. Factor the following polynomials. 36r to the second plus 48rt plus 16t to the second. The greatest common factor is greater than 1. So even though 36r to the second is a perfect square on the left, and on the right, 16t to the second is also a perfect square, the greatest common factor is still greater than 1. So if it helps, you can write the prime factorization of 36. So 2 is a prime number. 2 times 18. 18 is 2 times 9, and 9 is 3 times 3. So this is the prime factorization of 36. The prime factorization of 48. So 2 times 24, but 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So this is the prime factorization of 48. And the prime factorization of 16. 2 times 2 times 2 times 2. So the greatest common factor of 36, 48, and 16 is how much?
4.
Yes, 4. Or 2 times 2. So each of those prime factorizations has at least 2 factors of 2. So the greatest common factor is 4. Okay, so we factor 4 out of all of the terms first. And when we factor 4 out, we're left with 9r to the second plus 12rt plus 4t to the second. Okay, inside the parentheses, 9r to the second is a perfect square, and 4t to the second is a perfect square. So we wonder if the middle term, the trinomial, is also a perfect square trinomial. Okay, so if we look at that over here in isolation, 9r to the second plus 12rt plus 4t to the second, we want to see if this has the right form for a perfect square trinomial. So 9r to the second is the same as squaring the term 3r, And on the right, 4t to the second is the same as squaring the term 2t. So we want to see if the middle term plus 12rt has the form plus 2 times 3r times 2t. And sure enough, 2 times 3r is 6r, and 6r times 2t is 12t. So it is a perfect square trinomial. The two binomial factors are the same. So in this case, the two binomial factors are 3r plus 2t times 3r plus 2t. Okay, so over here, our complete factorization includes the factor 4 and then the two binomial factors 3r plus 2t times 3r plus 2t. Okay, the next example, 25c to the second plus 16e to the second. The term on the left is a perfect square and the term on the right is a perfect square, but since we're adding them, we say this is not factorable. What we really mean is that it's not factorable with real numbers for coefficients. So we just say it's not factorable with real coefficients. What if it were 25c to the second minus 16e to the second instead? Well, this is a difference of squares. A difference of squares is factorable. So if it helps, you can write it as the term 5c squared minus the term 4e squared. And a difference of two squares is factorable. One factor is 5c minus 4e. The other factor is 5c plus 4e. Hey, the next example, 81v to the second minus 180vy plus 100y to the second. The greatest common factor of all three terms is 1. Notice the term on the left, 81v to the second, that's a perfect square because if you square the term 9v, you get 81v to the second. The term on the right is a perfect square, 100y to the second, because if you square the term 10y, you get 100y to the second. So we want to know if the middle term has the right form. So does it have the form minus 2ab? Well, we just put those in. So we're wondering if this has the right form. So we haven't verified that this is really equal yet. So it's minus 2 times 9v times 10v. Sorry, not 10v, 10y. 9v times 10y is 90 vy, and 2 times 90 vy is 180 vy, and we're subtracting. So yes, it checks out. This is a perfect square trinomial, so the two binomial factors have the form a minus b times a minus b. So our factors for this trinomial are 9v minus 10y times 9v minus 10y. When the binomial factors are the same, it's okay if you write 9v minus 10y squared. Okay, the next example, 121c to the second minus 36c plus 49. The greatest common factor is 1. So we have about 2 minutes left. So it's pretty easy after you find the factors. It's pretty easy to type them in. So work on this for a few seconds and type in the answer. Well, time's running out. So 121c to the second is a perfect square. That's the same as squaring the term 11c. 49 is the same as 7 to the second. So is the middle term, does it have the right form, minus 2ab? So negative 2 times 11c times 7. Well, the middle term is different than minus 36c. So, okay, we're out of time. Go ahead and sign in for attendance.
Have a good day.